Hello students, I have told you that the gas equation PV equal to RT is not true at very low temperature and high pressure. That means for the real gases. So there must be the correction in the pressure and volume of the gas equation, and it was made by VanderWall. This is called the equation state of the real gas. Equation of state of real gas, and this we see the VanderWall gas equation. VanderWall gas equation. The equation PV equal to RT is not true for real gases due to the postulates of negligible volume of molecule and no molecular force of attraction. Because in postulate this was found that the volume of the molecule is negligible in comparison to the volume of the gas, and there is no molecular force of attraction. No molecular force of attraction among the molecules. So it means that there must be the correction in pressure and volume. So VanderWall made correction in pressure and volume. So first we take the pressure correction. Pressure correction, or more better, let's new equation PIVI equal to RD, where PI equal to real pressure of or pressure correction VI, the volume correction. Or the real volume. So first we take the pressure correction. You can see that suppose this is the container which is closed, and here is the molecule. Suppose then it will have the forces like this. This is the free molecule, but when this molecule comes near this ball or this face, then there will be this molecule. So this is the position A and this is the position B. So molecule at when the molecule is in the position B, then the pressure exerted by this molecule will be less than the pressure of the ideal gas. At very high pressure, the molecules of gas come close to one another. To one another, and they affect the motion of the molecule. The observed pressure is less than actual pressure. Due to molecular force of attraction. It means that the observed pressure is less than actual pressure. Actual pressure means pressure due to ideal gas. Due to ideal gas, and this observed pressure means pressure means pressure due to real gas. So therefore actual pressure equal to observed pressure plus pressure correction. Lack in pressure. So this actual pressure is what? The Pi is equal to P plus small p. Small p is the pressure. This is the lack in pressure. This is not P. Where P equal to lack in pressure. And this is found that lack in pressure is equal to P is proportional to square of density. So P proportional to m upon b square, or P proportional to m square upon b square, and we can have P equal to K m square upon b square, or P equal to A upon b square, where A equal to K m square, m the mass of the gas or the molecular mass, called the VanderWall constant. Hence actual pressure Pi is equal to P plus A upon V square. Second, the volume correction at very high pressure and very low temperature the volume of gas molecule is not negligible. In comparison to gas volume. Gas volume. Since the molecule come close to each other, so the gas volume is very less. At that stage, the volume of the gas of the molecule is not zero or negligible in comparison to the gas molecule. So let B equal to volume of molecules. Then the volume available to move the volume available to move freely. Is less than volume of gas. Volume of gas. So, the volume correction VI equal to V minus V. So much volume will be available for the molecules. You can consider that, suppose for example, we can give to an example to this one. Suppose there are 10 students who are playing in the ground. Then the volume of one is student will be negligible in comparison to the volume of the ground. And if suppose this ground is made to be very small, then the motion of the students will be affected by each other. So they will not move freely as they were moving freely when the ground was very big. So now the volume available will be less than the actual volume. So the volume of the gas minus the volume of the students, that will be the volume available for the students to move in the ground. Similarly, the pressure, when they will be close to each other, then definitely they will affect the motion of one another. And as a result, the pressure will be, the observed pressure will always be less than the actual pressure. So these are the two factors when the pressure is very high and temperature is very low. So the new gas equation. So now in place of Pi and Vi, we write on P plus A upon V square, and this is now V minus V. Therefore, the real gas equation P plus A upon V square into V minus V equal to RT. It is called VanderWall Gas Equation for real gases. Where A and B are VanderWall gas equation. VanderWall gas constants. And now you can have that this term will have the volume that we can take it to be later, that what the A, what is the V. So that we have not to find here, but this we have to tell us that this A and V are called the VanderWall gas equation. Now this gas equation is fit for all the real gases at the room temperature or at very high pressure and very low temperature. So you like, share and subscribe this video. Thank you.